chlorofluorocarbons.
CFC.
Let's look at a quick overview of chlorofluorocarbons. Chlorofluorocarbons are chemicals made from chlorine, fluorine, or carbon. Scientists use them as a non-toxic, non-flammable alternative as opposed to toxic refrigerants like ammonia and sulfur dioxide for about 78 years. They were used in refrigerators, air conditioning units, and aerosol cans. Later on, they were found to be damaging to the Earth's ozone layer. This is a covalent bond, and chlorofluorocarbons are a tetrahedral molecule. Let's look at the impact on the environment. Greenhouse gases are atmospheric gases that trap heat from the sun near the Earth's surface, acting like a planetary blanket. CFC's primary introduction to the environment comes from man-made products. Once they find their way into the environment, CFCs rise to the stratosphere where they break down under ultraviolet radiation, releasing chlorine molecules. These chlorine atoms catalytically destroy ozone molecules, leading to the formation of the ozone hole. These holes are often found over the North and South Pole. Chlorofluorocarbons are dangerous to animals, humans, and plant life because they thin the ozone layer, making it easier for dangerous radiation to get through. Some pros of chlorofluorocarbons are they are non-toxic, non-flammable, and inexpensive to produce. But the drawbacks or the cons really outweigh the pros because they deplete the ozone layer of its durability to protect humans. What has the United States government done to fix this? Well, the government has regulated CFCs by banning almost all production, imports, and non-essential uses of the chemical. This was done by the United States Environmental Protection Agency.
Ways we have fixed this issue. The problem that CFCs have brought to our environment was a significant change composed of carbon, fluorine, and chlorine. These compounds were highly stable in the atmosphere, persisting for decades, and when they rose, they hurt the ozone layer, damaging it significantly. Once in the stratosphere, the radiation from these CFCs molecules released highly reactive chlorine atoms. And once again, these chlorine atoms break down into thousands of little particles and hurt ozone molecules. New classes of chemicals such as hydrofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluor have shorter atmospheric lifetimes than HFCs. So this means that it breaks down faster in the atmosphere, and so when it reaches the stratosphere, it does not hurt the ozone as much as the CFCs would have.
The Fitness Gram Pacer test is a multi-stage aerobic capacity test that progressively gets more difficult as it continues. The 20-meter pacer test will begin in 30 seconds.
I summarized a research article from the ASCNHCL, short for American Chemical Society National Historic Chemical Landmarks. Boy, is that a mouthful. Experimental methods that they went over were they published experimental data on CFC concentrations. They used chemical reaction equations to look at this different data. They took mathematical calculations and atmospheric models to look at all these experimental ways and methods. They researched and analyzed how long CFCs stay and live in the atmosphere, and predicted how the UV light would break these CFCs apart in the stratosphere.
Line up at the start. The running speed starts slowly, but gets faster each minute after you hear this signal. A single lap should be completed each time you hear this sound. Remember to run in a straight line, and run as long as possible.
Our conclusion from this was CFCs can remain in the atmosphere for many years on end, and the UV radiation breaks down the CFCs in the atmosphere. And the chlorine also destroys part of the ozone layer.
Now let's take a look at this graph. This graph right here is going to show us the global emissions of CFCs and how the emissions have gone down since global regulations. So if we look here on the first and third and fourth and fifth and sixth and second graph, you can see that around the 1980s, 1990s, that was really a peak, and then once regulations hit, that's just diving straight down. And that's really going to be what is going to keep our ozone layer nice and good to keep us protected from the sun's rays. Make sure you remember that. And now we conclude.
Start.
Our presentation on chlorofluorocarbons.
1.